possibilities that lay ahead for humankind. But of all the sci-fi superpowers that we could develop, time travel surely ranks high in terms of its potential to change the world forever. So, are we almost ready to finally make that breakthrough? The debate surrounding time travel is as old as, well, time. For decades, even centuries, humanity has been considering whether it could ever be possible to move not only through our spatial plane, but also through a temporal one as well, more so than just into the future 1 second at a time. Rather, we're after true four-dimensional living, where the past is never truly over, and the future is always worth a visit. The flux capacitors of Hollywood films have certainly inspired imaginations over the years, with the quest for time travel almost inevitably bleeding over into the race to achieve faster-than-light movement. But now, with arguably a new age of technological exploration only just beginning, have we finally found the key to open this particular door? Theories surrounding quantum physics are hardly new news in themselves. For much of the 20th century, scientists were busily getting to grips with the subatomic realm, describing atoms, splitting atoms, and discovering all of the even smaller parts that make even the atoms themselves look like vast and complicated structures. Today, the quanta, the tiniest packets of reality, are reasonably well known, and though the standard model remains an incomplete and ever-evolving concept, we are now putting it to practical use in the here and now macro world with quantum computing. This is something we've covered in previous videos, but to recap briefly, because it could actually be crucial to the question of time travel specifically. While traditional computers carry standard binary bits of information understood as ones and zeros, the quantum bits, or qubits in quantum computers, can be either a 1 or a 0. This freedom dramatically expands the processing power they offer, and it's here where the genuine possibility for time travel comes in, because some believe that quantum computing will actually be powerful enough to bend and break the rules of time. We already know that at the quantum level, the laws of physics somewhat fall apart. Quantum entanglement enables apparent speed of light travel. Quantum data can easily move between wave and particle states. Quantum superposition enables chunks of subatomic information to apparently be in two places at once. We know that all of that's already true. So, next stop, traveling back into the past. And multiple experiments seemingly have already shown that it is possible. Perhaps the first murmurings of quantum time travel came in March 2019, when details emerged of a multi-authored paper from an international team based in Russia, the US, and Switzerland. According to a report from the Moscow Institute of Physics and Technology, or MIPT, physicists were able to reverse time using a quantum computer. To set the scene, the MIPT explains how an isolated electron in a vacuum of interstellar space, i.e., how the tiniest bit of reality in the least chaotic conditions in the universe could, theoretically, be smeared between the present and the past for a tiny fraction of a second. It's suggested that a random fluctuation in the cosmic microwave background radiation, or CMB, might achieve this, although the chances of it happening are extremely, extremely low. As the MIPT puts it, even if you spend entire lifetimes of the universe again, watching 10 billion plus electrons for every second of that existence, then you'd only see an electron smear back in time once, and only for much less than a second when it did so. Scientists are patient people, but they're not that patient. So the team set about applying what they knew to a quantum computing exercise, hoping to crunch those incredible odds all the way down so they could eventually reverse time on demand. And to some extent, they succeeded. Using a relatively simple 2-qubit setup, they were able to set those qubits into life before effectively pausing them and sending them back to where they came from, back in time. All the information within effectively untouched, and order seemingly restored out of growing chaos. With the 2-qubit computer, the team was successful 85% of the time. When they added a 3rd qubit, that rate dropped to 50% of the time, and were they to have added more, the rate would likely have continued to fall with every added complexity. But nevertheless, on some level, this could be described as real, true, observable, and possible backwards time travel. Just over a year later, in July 2020, news broke of a joint research project out of Los Alamos National Laboratory. Here, in a study involving another quantum simulator in a similar, although not identical setup to the MIPT experiment, researchers were able to show that the fabled butterfly effect didn't take hold at the quantum level. The butterfly effect is the theory that even small changes in the past can massively alter the present, and the same for the present into the future. But when the Los Alamos team ran qubits through their quantum processor, again as through back into the past, but then altered them ever so slightly, it was found that very little effect was still noticeable when those qubits were brought back to the present. They hadn't carried the altered information through in any meaningful way. Could this, then, be a sign that quantum time travel is not only possible, but potentially safe as well? Finally, in late 2022, reports were that there had been 2 independent studies published within days of each other, both achieving a quantum time flip, specifically with photons, the subatomic particles of light. This time, it wasn't a quantum computer at the heart of the experiment, but a specifically structured crystal. Although it's claims that there could be major implications for quantum computing in the future. In short, the studies passed split photons through the crystal, making use of quantum superposition, and upon measuring them afterwards, when they'd recombined, they found that while one split had continued along the expected arrow of time, the other had turned against it. At its heart, this could be seen as in direct defiance of the second law of thermodynamics and entropy, probably the trickiest barrier between us and time travel in general. Ordinarily, entropy says that everything is always moving from order towards disorder or chaos. It never goes the other way, which is essentially why we have the concept of time moving forwards in the first place. But here, with photons shot through a crystal, it would appear that actually, to some degree, physical matter and energy can move in the opposite direction, in an anti-direction. Although the fact that the photons are split is important. Ultimately, this isn't time travel just yet, and certainly not in any practical sense. It's more a parting of ways at the quantum level, and yet another subatomic mystery for science to add to its growing list. Utilize those or similar crystals within quantum computers though, and the already boundless states of a qubit potentially increase even further. The possible processing power soars again. For now, with all 3 of these studies, we can't truly claim that time travel has been discovered via quantum computers. But could these projects yet prove to be the seeds for even greater ideas and breakthroughs? Today, we're smearing qubits back into their own past, recording how changes do and don't register, and sending split particles into a seemingly impossible realm.